There you go. Welcome, everyone. Thank you very much for being here. We really appreciate your presence tonight. We have a really fine audience. Actually, we had uh, almost 130 subscriptions. We have right now about 40 people with us, and the subscriptions were from all over the world, more than 30 countries, more than 30 nations subscribed to. So you can see that this session has a very interesting topic. We're going to talk about bath level solutions, some of our finest bath level solutions that we developed and implemented together with our customers at Nucor Steel. We have here with us today two very special guests with us from Nucor Berkeley and Decatur branches that we are going to give some time that they explain as well about the process and all about the solutions. I will give some time as well for the presenters to introduce themselves, but right now I would just like to state that the session duration will be for 1 hour. We will have a 45-minute presentation and a 15 minutes later some question and answer sessions. We had already some questions addressed to us in the forms, in the registration forms. We will be addressing them as well. And I would like also to state that if anyone has any questions or they want to have any comments, they can just write down in their chat. For avoiding distraction purposes, we are not allowing cameras and microphones in these sessions because we know from previous experiences that sometimes by distraction someone forget their phone, their microphone or their camera turned on, and then it interferes a little bit in the presentation. But please feel free to address any questions that you have on the chat, and we'll be very pleased to answer them. And so first of all, a little bit about Vesuvius Digital Services. So this is a recently incorporated division to the Vesuvius Group. So the Vesuvius Group is a very traditional group based in London, and it was actually founded in the 1800s. So it's a very traditional and has been through all this time creating solutions and for the steel making and the foundry industries, and has recently, starting from 2014, a process of incorporating the Vesuvius Digital Services division to bring some innovation to their solutions and to their processes. We will be having some talk. Rafael will explain a little bit more about our portfolio in the next slides. And also they will explain a little bit about Nucor later. Now we will have some time for our presenters to introduce themselves. So please, Rafael.
Thank you, Pedro. Welcome, everyone. So my name is Rafael Jacob, and I am Global Marketing Technology Manager for Vesuvius Sensors and Probes. So I basically take care of R&D and product development. So I'll be the technical guy here today, all right?
Thank you very much, Rafael. And now we have also Daniel Holmes from Nucor Berkeley.
Hello, my name's Dan Holmes. I'm a melt shop metallurgist here at Nucor Steel Berkeley. It's located in South Carolina, United States. Been here for about 8 years with Nucor Steel Berkeley and work mainly at the electric arc furnaces and the raw materials scrap areas at the mill.
Thank you very much, Daniel. We also have Garrett Finnan with us.
Hey, Garrett Finnan. I'm also a metallurgist that works for Nucor. I'm in the Decatur plant, which is in Alabama in USA. And I also primarily work in the electric arc furnace area and a little bit in the scrap area as well.
Thank you very much, Garrett. And also we have our representative in the USA, Keith. Keith, you're on mute.
Hello, everybody. I'm Keith Updegraff, Sales Manager USA. We take Rafael's ideas and try to implement them in the steel mills across the country. And I just want to say a special thanks to Daniel and Garrett for working with us on this, because they've worked with us quite a bit on this. So thank you for your guys' time.
Yes, excellent. We also really wanted to appreciate and to thank our guests here. We really appreciate that you're here and that you supported us in this presenting these solutions. And now we're going to Rafael is going to present a little bit more about the portfolio of our solutions.
Thank you, Pedro. So following Pedro's presentation about Vesuvius and Vesuvius sensors and probes, I'm going to talk about our 8 main product families just quickly, so as the ones that are not familiar with Vesuvius sensors and probes understand. But we produce disposable probes and sensors for acquiring and controlling the variables of the metallurgical processes. So not only in steel plants, we also cover foundries, but the steel market's it's our main focus for sure. So we have, of course, our temperature probes, so different types of probes for all the areas actually of a steel plant. So from the blast furnace to the continuous caster or even ingot caster, we have temperature probes for all the areas. The thermoanalysis cups are products that are dedicated actually to foundry. There are some versions also for steel, but they are not used so much nowadays. We have also samplers. We have a great variety of samplers for also all the areas, again, from the blast furnace to the caster. We have also combined probes, probes that combine actually most of the features that we provide to the market today. So temperature and samplers that I already mentioned, and also the other ones that I'm going to mention soon, like oxygen, which is the next one. So oxygen probes are actually extremely important. From the oxygen probes, we are able to predict many other variables like carbon, like aluminum, like FeO, like silicon in the blast furnace. So oxygen probes are actually a very special product line. We also have the hydrogen probes, which are used normally in the secondary refining and caster to control the soluble hydrogen in steel. We also have a line of products specialized for BOFs. So basically sublance probes, which are used in sublance systems, and drop sensors, which are used in usually mills that don't have the structure to have a sublance system installed. And we also have another 2 product lines, which are basically the accessories for all our sensors. So in Vesuvius, we are vertically integrated. We produce the full solution in-house. We develop and produce. So not only all the sensors that I mentioned, but all the lenses, cabling, wiring that are compatible and designed for the best functionality of the sensors, and also the instruments, which are our interface with our customers. So they are also extremely important. So this is just a general overview of what we do. But with all that, we actually do much more. We make other developments. We do a lot of customization for some customers, and we work together with the customers, and you will see a little bit of that today. Thank you, Pedro.
Thank you. And now Jen's going to present a little bit about Nucor Steel.
Yeah, just a quick background on Nucor Steel. Nucor started kind of its current form as a steel maker in the 1960s. Nucor is one of the largest steel producers in the United States, with about 27 million tons of steel making capacity, 27,000 teammates within the Nucor, the Nucor family, 300 operating facilities. And Nucor is the #1 recycler in North America. So that's just a quick background on Nucor and who we are.
Thank you very much, Dan. Now a little bit about the equipment, operative capacity.
So specifically for Nucor Steel Berkeley, Nucor Steel Berkeley started up in 1996. We currently have 2 CSP casters and 1 beam caster, and we're located in South Carolina, again in the United States. At the melt shop, we have 2 electric arc furnaces, and they feed 3 casters. So two of the casters produce coils, one produces beams or bars. Our markets that we serve are automotive, agriculture, construction, transportation, power generation, pretty much anything that consumes steel. We make something for at Nucor Steel Berkeley. Specific to this presentation, the 2 EAFs at Berkeley are direct current or DC furnaces. They're EBT or eccentric bottom tapping furnaces, and a typical heat size is about 170 tap ton net tap tons or short tons. On the average, we carry about 100-ton hot heel, depending on furnace age and furnace life. And then we do measure temp and oxygen on the sump side of the furnace, so on the actual above the tap hole of the furnace. Some mills measure temp and oxygen through the slag door, but we do it on the back side of the furnace or the sump side.
Excellent. Now Keith's going to talk a little bit about the solution.
So our solution to be able to do this, we use oxygen probes, with which Raphael will explain a little more. But some of the advantages of it are, allowing for slag-free tapping for the EAF, protect the bottom anode in a DC furnace from oxidation, overheating, and damage while charging the furnace, allowing for efficient burner and foaming slag operation, and assist in pre-melting the scrap. So, and as you can see, this furnace is EBT, as Dan said, and the next one they're going to talk about is the same, but they do take it from a different area, which I'll let Garrett talk about, how they measure their bath level. At Berkeley,
thank you very much.
It's measured out of the sump.
Excellent, great. Thank you very much, Keith. And now Raphael is going to talk a little bit about the working principle for the solution.
So, basically what we are doing to measure bath level today, what is the solution that Vesuvius is offering for EAFs? So basically, we use the oxygen probe, as Keith mentioned, and some of you will probably think, well, this is actually an old solution. And actually, it's started from an old technology. So there is a known technology that we use, which is it's basically on the principle that the oxidation of the slag is very different from the oxidation of the steel. So for the ones that are familiar with an oxygen measurement, if you look on the left side here, you may recognize this is an instrument for acquiring and showing an oxygen measurement. So the red line is basically the temperature, and the blue line is the oxygen. So when a disposable probe is immersed into the steel, you have a period of stabilization. So you see the traces going up. So the temperature going up, the oxygen cell, which is the main part that makes the detection of oxygen, also gets thermally stable. And then you see those traces. When we have the stability, which we call plateau, we take the oxygen measurement. So, and then we're going to get how many ppms of soluble oxygen are in the steel. We can also predict carbon and other variables. But when the probe is being retrieved and it crosses the slag, the oxidation goes high. So you can see on the red circle, which is what we call trigger, it goes up. So I'm going to explain exactly how it's done in the next slide, but basically we are able to detect the exact moment of when the probe crosses this interface. And what changed? So as I said, this was used in the past a lot, especially in BOFs with sublance applications. But it was a little limited in terms of accuracy due to the technology that was available at the time. So basically what Vesuvius did in the last few years was to use the better computer processing technology, electronic technology, and especially some differences on the algorithm that made it much more accurate. So something that was not very good for an EAF in the past, because you see that in the graph actually in the picture on the right, you see them showing an immersion of an oxygen probe in an angle, and this makes a big difference actually. It's why in the past, it's the main difference why in the past it would work for a BOF, which is normally straight in a sublens application, but not for an EAF, which many times is in an angle. So by having a better acquisition time, a better acquisition rate, we are able, and a better algorithm, we are able to be much more precise. So if you go to the next slide, Pedro, you guys are going to have now an idea of how is the installation setup. So it's going to make it more clear. So you have, of course, your application, your EAF or BOF, but here we are focusing in EAF, which we have first connected or in contact with our sensors. And here I'm talking about the application at Berkeley. So we have also a wireless acquisition. So we have a wireless transmitter. So we don't have a very long cable coming from the manipulator to the pulpit. It's completely wireless. This was also a limitation for BEF level in the past, because you also have the limitation of the wireless transmission. So, and you also have from the EAF, the pole position, so the manipulator position. This is very important for any BEF level application. We need an automatic immersion, so we need a manipulator. In this manipulator, we must have a sensor, a position sensor, which can be a resolver, an encoder, in some cases an inclinometer, which will transmit, in this case, via 4 to 20 milliamps, which is an analog transmission, because it's actually the most reliable in terms of timing for our steel lab. So our steel lab is basically the heart of the system, who's going to be receiving wirelessly the temperature and oxidation and the position of the manipulator. This is going to be processed. We're going to get a BEF level, and it's going to be sent for the PLC for the data purposes at the customer. And what are the main advantages that we can see right away? First, and this is going to be, we're going to talk about it after, but it doesn't require a specific sensor for BEF level. We use the regular oxygen probes. We are able to provide level in every oxygen measurement. We have a high acquisition rate, so it goes up to 100 points per second, and allows more so that allows more accuracy. And it also, our lab, and I will show very soon these details, it shows customized calculations. So we can customize our lab for the needs and the use of each customer. Okay. Can go to the next one, Pedro. So here, this is basically a screenshot of what we did and the results we obtained at Nucor Berkeley. You can see our lab here, and you can see that apart from temperature, oxidation, and carbon, we are also showing other 3 variables, and in which it's measured in inches. So this is actually BEF level variables. So the first one is the actual BEF level. So this is basically the distance between the slag and steel interface and the bottom of the furnace, which in this case is basically the tap hole, from the tap hole to the interface. So those are the 33 inches. And then there are other 2 variables that we customized that are very interesting. Actually, this idea came from Nucor Berkeley. They want to have a prediction of what was going to be their hot heel. So basically, what we calculate, and this is something that we developed together, is from the BEF level, what is going to be the heel if I tap 160 tons, and what is going to be my heel if I tap 175 tons. So this is quite interesting for the operator, because he will already know what's going to be there after tap. So he can actually decide how much he will tap to keep the heel that he wants to keep. Okay, so this is actually quite interesting. And well, basically, and of course, the trick that is in the improvement of this technology, I cannot give away in all details, but the most important is that it's on the electronics, software, and also in the improvement also on the probe precision, because it is very important to have high acquisition speed. And it also depends, and this is something that we can discuss, I'm sure it will come up, it depends also on the speed of the manipulator. So those are all very important variables to have an accurate bath level.
Okay, thank you very much, Rafael. So this was the application case for Nucor Berkeley, and as we said, we have some quite customizable solutions. And now we're going to talk about what is the other specific case that we have here to present today. And this is the case that Garrett will present us for Nucor Decatur.
Yeah, so at Nucor Decatur, we're similar in a lot of ways to Berkeley. However, we don't have the extra bar mill that Berkeley has. We do have 2 SMS CSP casters. Our production is about 2.8 million tons per year, but we do have an upgrade that's in the works that to our transformers that will bump us up to around 3.2 million tons. We have the same product line when it comes to Berkeley on their sheet side, so we are pretty heavily invested into automotive as well, and some of the other similar products. But the main topic for this, though, for the furnace and Vesuvius's bath level measurement, the main difference that we have on our furnace side is actually where we take our oxygen temp from. We are still a DC furnace, direct current. We also tap about 168 to 170 tons, and we are also an eccentric bottom tapping furnace. We do have a sump as well, but our sump has not as much room as Berkeley has, and we don't have enough room for our operators to go up there as often, or enough room to add in a robot or anything like that to where we can start taking temperatures and oxygens from the sump. So we have to do it from the front. We also have our setup for our screen a little bit different as well. The only information that we really look at is our temperature, our emissivity, our oxygen, and our carbon. The bath level measurements actually are taken as an average and sent to our level 2 system, which puts it on a heat report that our operators are looking at, during the process for every heat. And we kind of use this as a way to validate our scrap mix yield and make sure that, we're not pulling from that yield just to compensate for a lower yield in our scrap. So it helps us identify issues if we're having out in our scrap yard, and also making sure that the mixes that we're putting into our furnace are, well suited and have a good high yield and everything. Another big portion of this that Dan will talk about later is going to be safety for us. We have to get a heel depth measurement manually with with operators' eyes. We have to walk out in front of the slag door. The issue with this is that if there's ever an instance where something falls into the heel while the slag door is open, it can cause a splashback, and some slag could actually come out of that slag door and potentially hit the operator. So having this measurement where it keeps the operator out away from the slag door is a huge safety improvement for us as well. If you look at the photo on the left, that's actually our deck, and that shows our slag door where I'm talking about. So our operators will walk back and forth over there, but primarily with the slag door closed. So the only way for us to see inside the furnace is with that open, and that's where you have a potential for splashback. So this has helped us in understanding our scrap and understanding our yield, and also keeping us a lot safer in our processing as well. So overall, very great project, and we're thankful for Vesuvius for helping us out with this.
Excellent. Thank you so much, Garrett, for your input and to present this very fine solution and customized for this project specifically. And now Dan's going to talk a little bit more about the perceived benefits. Garrett already spoke a little bit, but Dan's going to talk a little bit more on the benefits for their perception on the core side.
So kind of I guess the history of this project is around late 2018, Berkeley was approached by Vesuvius with their solution, their temp oxygen and bath level probe. The main interest from Berkeley, as Garrett alluded to, was safety. Our old practice, we would go up on the sump side of the furnace. An operator would take an oxygen lance pipe, drop it down until it touched the top of the tap hole. The steel, the hot heel in the furnace, that steel would melt away the lance pipe, and then we'd take that, throw it up against a ruler, and we would measure the actual depth in inches or whatever of the hot heel, and that was our direct measurement for hot heel depth. There's safety concerns doing that because you're exposing a teammate to molten metal. I mean, obviously we have all the right PPE and procedures in place to keep it safe, but it's still a situation that we'd rather avoid. So that was our main interest, was the bath level measurement, that we could do that automatically rather than having an actual teammate do that process to grab us that information. Again, as Keith said, that bath level measurement, it's very important. It affects the furnace efficiency, like Garrett talked about. It affects our scrap yield, how the furnace runs, furnace life, all sorts of good things. So we have to know it. It's a variable that we need to understand, and this system allows us to do it in a better way than we used to. So specifically on the safety part, when we began using the system in September of 2019, we put it in, operators started playing with it. We started getting comfortable with the data that the bath level was showing us. And then over time, operators became more comfortable taking less of the manual heel checks and relying more on the Vesuvius bath level number. After the system matured, we were able to reduce our manual heel checks by about 34%. The frequency, or the times per day that we're actually taking a heel measurement, which equates to a safer operation, less teammates on the sump directly measuring the heel level. We'll go to the next one. So I guess a side benefit of the bath level system was that it did help us reduce delays. Since the bath level system allowed us to take less of these manual heel checks, which is kind of an involved process and takes some time to do, we were able to reduce those delays, and on a time basis, we really reduced them by about 34% just by taking less of them. We always take a temp and oxygen. You take multiple heat because you have to know what the temperature of the steel is. You have to know what the carbon is for downstream processing at the LMF, so they can do what they need to do to get the right chemistry and temperature for the heat. So we're already taking a temp and oxygen. Now we're getting a bath level reading as well with the same probe run. So there's no time, that's free time, because that's a number that we're just getting that we're gonna do anyway. So that has helped reduce our delays for heel checks. So all in all, Berkeley's been happy with the results from the Vesuvius system. Our main goal was to reduce teammate exposure to molten metal, and we did by 34%. We also reduced the delays on taking manual heel checks by about 35%. And every time we take a temp and oxygen, now we get a bath level probe, or most times, which gives the operators, more data to work with. It gives them the ability to make better decisions on, incoming scrap, what they should tap, anything we should change in the process. to keep our hot heel where it needs to be for efficient furnace operation.
Excellent. Excellent. Thank you very much.
One thing I just wanted to mention, sorry, Pedro.
Of course.
You know, this used to have to be like a specific probe, but Rafael's team managed to make this work with an oxygen probe, which most EAFs take anyways. So you don't have to put a separate probe on. You're able to use the same probe to do this prediction, and that's been a definite game changer for a lot of plants, that they don't have to carry two different probes to get a bath level.
Yes, definitely, and it's definitely something that increases the efficiency, and something that we can work on. And and the real nice thing about this is that it's customizable to each situation and to each project. That we can ensure that we will study and give the right type of needs for your project that you need to have. We have all of our specialists and very technical expertise that have all this knowledge to understand your situation, understand your needs, and provide the best solution for your project, for your needs, for your activities. And this is really great. We really appreciate it. Was very nice. First of all, I would really like to thank you guys for being here with us tonight. Dan and Garrett, we really appreciate your presence here. It's been amazing that you're available to present these solutions with us here. We really appreciate the partnership with Nucor, and we really want to continue further with this partnership. And so now we have a question and answers. We have a few questions that people. I'm not sure if anyone wants to add anything. Maybe Dan or Garrett or Rafael want to add anything else from the project itself and the solution and the presentation, or if we just jump. Sorry.
I was going to say, Pedro, as you said, one of the biggest differences too is, you know, you've got Decatur going through the slag door, and you've got Berkeley going in the sump. So like you said, we can make adjustments to help in different situations, because those are two totally different applications, but doing they have the same outcome.
Exactly.
Yeah. An important point taking from where Keith stops is that it's something that has to be done between Vesuvius and the customer. So we cannot just go together and just by ourselves and start measuring bath level. So we need to check the furnace dimensions, where there's a lot that we have to do together, and also understand the needs of the customer. So it's very important for us to understand what they want with the bath level measurement. So Dan and Garrett presented many advantages, but eventually another customer may have a different need specifically, and then we can work together. So this is quite important. This, let me say, customized or specially made solution. It's quite important.
Exactly, for sure. So now we have. So should we jump into the question and answers, or do we have any other comments? Okay, let's go into the question and answers. So now we have Ruth Angel. Our guest Angel is asking us. Thank you for the nice comment, great presentation. And then she say, how well does this work with spout furnace, and also does it work when melting stainless?
Look, I don't know exactly what he meant with how well. I think this is something that we can even after my answer see from Garrett and then their perception. But if you're talking about accuracy, this is something that will change a lot application to application, because it depends on the speed of your manipulator. So if you are able to control the speed of manipulator, especially, the slower you get, the more accurate you are. So of course you cannot be too slow because it also affects the life of your lens and manipulator. But in our solution, it's important that when you are retrieving the probe from the furnace, you don't do it extremely fast, so as the speed, it allows us to actually read. So in general, we aim to be at least on the plus or minus 2 inches of accuracy. Sometimes we're able to get more, sometimes we're able to get less. But it depends really on the work that we do together. But I don't know if Garrett or Dan, if you have anything to add on top of it.
Yeah, for the accuracy, at least for Decatur, to your point, it kind of adjusts a lot with the speed. So we actually end up averaging a lot of ours together, and then that's what ends up getting sent to level 2, and then we use that as our number for our heel depth. So we take an average over. We'll take 2 or 3 temps or so, and they're typically very close together. So that average helps kind of get rid of that potential variable there.
Yeah, which reminds me, Garrett, another important point. You have to remember that we are looking at the interface, so basically a line between steel and slag. And depending on where you are in the process, it may be not something completely even and straight. So if you are arcing and blowing and injecting carbon on everything, and everything is shaking there, this line is not going to be extremely precise. So the more steady the furnace, the better. So, but as Garrett said, in their case, they managed to take an average, and it's actually pretty accurate in along the heat. But obviously, the ideal would be to have always the furnace in the same angle. Of course, if you tilt it and take it in different positions, you're going to have a slightly different result. And also the bath steady. So this is actually quite important as well.
Yeah, we actually have our posts that some that we send out to the team is that whenever they are taking a bath measurement is to have the furnace locked on the post while taking that measurement specifically for that reason. So that is something that does help. And it does cause changes there, so we know that that's something we can help out as well.
Excellent. Thank you very much for all the comments. Thank you very much, Ruth, for the question. And now we have one more question from Javier. And he say, is the supplier the one who provides the encoder? Most of the automatic lenses already have the encoder.
In our experience, yes, most of the manipulators already have the encoder because the supervisory automation system of the customer wants to understand where is the manipulator at all times. However, if there is any customer that doesn't have an encoder in their manipulator, we can help them with that, no problem. We can specify a type of encoder, resolver, or sensor that would work in his application and work with our system.
Excellent. Thank you very much. Thank you, Javier, for the question. Now we have a question from Greg Connor. What was the initial correlation between manual pipe measurements and the new probe measurements? And has this improved over time?
I don't know, Dan, do you want to?
Yeah, so I mean, initially we have to set up the the encoder, and you put a laser on it, measure the depths, as the lance traverses through the furnace. And that's pretty easy to do. That's a good number. What we look mainly for at Berkeley, we're looking for a change, kind of like what Garrett was talking about. We're looking for a steady movement up or a steady movement down to tell us which way the heel is actually moving. That's more what we use it for than an actual hard number that says this, the heel's 8.5 inches. We're looking more for a change up or down, and that would trigger us to react, accordingly with tap weights or scrap.
Excellent, excellent information. Thanks, Dan, and thanks for the question, Greg. Now we have another question from Francisco Castillo. Do you make the volume estimation based on the refractory drawing and manipulator position reference?
That's actually totally doable from our side. I remember, Garrett, I don't know if this is still done, but at Decatur, I remember in the beginning wanted to measure or to estimate the volume of steel in the furnace from the bath level, right?
Yeah, that's correct. We asked about it and we started to look into it, but the refractory wear was one of the questions that got brought up, and I think we haven't really continued to invest time in it. We decided that the information that we're getting from the heel depth measurement was sufficient enough. There's a few times where we'll be able to tap our furnace, and whenever we're doing a drain for like a tapple or something, we can check and see at this point in our furnace at this bath level, then we know how much volume was in the furnace, and we kind of go based off of those numbers to get an idea of how full our furnace is. But we never really continued to look down, see if we could get a volume estimator from it.
Great. Thank you very much, Garrett. Thank you, Francisco. Now we also have a question from Nicolas Santos. You mentioned the possibility of determining the total mass of liquid steel. What is more than the steel level? How do you consider the refractory wearing profile? Do you have a laser to measuring the wearing time to time?
Yeah, that is actually a very, very similar question. And look, I don't know if Garrett or Dan wanna explain anything about how they monitor the refractor there, but it's something that from Vesuvius we don't have a solution, let me say, ready for that, but it's something that we could do by connecting a system that measures the refractory wear with the positioning of the steel slag interface. We can of course estimate the change over time, because most of the customers want to keep always the same level, so the volume of steel actually increases throughout the refractory campaign to the furnace campaign. But it's something that none of the customers we have so far are doing in this level of precision, but can be done.
Yeah, we never really pursued the volume once we started to get the depth measurement. That was about as far as we needed to go with it. The main thing that would have been helpful for volume would be knowing if we were ever going down to drain the furnace, we would know how much weight was in there and how many tons we'd have to tap and how many tons we'd have to be ready for another ladle to tap, and if we would need an extra ladle and questions like that. But over time, we kind of got comfortable with knowing those numbers, and it kind of just faded away after that.
Excellent. Thank you, Gary. Thank you, Rafael, for the inputs, the comments. And now we have another question from Samrat. He's asking, how valuable is it to extend the system to LMF to estimate slag thickness? Valuable for the dissolved slag estimation, likely.
That's a good question. I know we've talked about it, but I personally have not been involved with that implementation. Rafael, have you done that at any customers at the LMF?
Yes, we have some experience with that. Basically, from the Vesuvius side, what I can say is that we have been during this last few years consolidating, let me say, the actual bath level information, and we do have work in progress to get actually slag thickness estimation, but this is something that is going to go to the market soon. It's something that we're definitely going to talk about at a slightly later moment, but definitely I think there is value. I definitely think there is value.
Excellent questions. And please keep up, follow our LinkedIn page. We will be definitely going to be talking about this soon, as soon as we have more information and once we're launching the kind of solutions for this needs. Everything that we launch in the market and everything that we have on innovations, we will be launching on our LinkedIn page. I will be posting here the link for the LinkedIn page. So if you don't follow it, just click there and hit the follow button. Now we have, thank you, Samrat, for the question. Now we have one more question from Javier. He's asking if the best level signal, the best level signal is developed by a physical signal to the PLC. A physical signal is sent to the PLC while crossing the slag steel interface. How can we develop that signal in best level in the customer's PLC?
So basically, Javier, our system is able to send a signal to the PLC if the customer wants, for example, to double calculate the level, like we do actually at Decatur. So at the moment that the system crosses the steel and slag interface, it's basically the most actually efficient is to do an actual hardwire connection. So at the moment we cross, we actually close a contact and send a signal directly to the PLC. If it's an analog signal, it's actually more accurate. But we do have applications where we even do that through Ethernet IP. It's not as accurate but in one of the cases, actually it's a case in South America, it works. Okay, if it was a physical cable, it would be even more accurate. Now, what we have been suggesting, if you don't have the possibility of sending an analog cable to the PLC, we prefer to do that in our own labs, because it's basically an issue of time base of different systems. So you have to make sure that you have no delays. So since we have a probe moving and looking for a position, if you have a delay, you're going to be basically giving a different value. So usually you're going to give a higher BEF level if you have a delay. So if you don't have a hardwire a cable from our system to the PLC, it is more recommendable to receive the actual encoder in our lab. So the steel lab is actually able to read an encoder or a resolver or something like that. And then we're going to be reading at the same time base. Okay, so it makes it more accurate. But it's what you're asking is actually possible and done in a few customers.
Excellent. Thank you very much, Rafael. Thank you, Javier, for the question. Now, apparently, okay, there is one more question from Vinicio Fuentes. He's asking any effect on tap to tap times after this implementation?
At least for Berkeley, I guess the biggest impact would have been the delay reduction on taking manual heel checks. That obviously that's not every heat, but that, you know, it would bring down the average tap to tap time by some small fraction.
Excellent. Thank you. Do we have any other comments on this question? Rafael, want to add something?
I mean, it's going to make it more efficient, right, Dan? If you're keeping the bath level at the point you need it, when you charge it, it's going to melt the scrap quicker also. So, I mean, being consistent on that, it's going to make your furnace more efficient, which should improve your taps, correct?
Yeah, I mean, that's very true. There's a lot of noise in the data, though. It's very hard to tease out the effect of one variable, you know, accurately.
Makes sense.
Excellent. Thank you, Keith. Thank you, Dan, for the inputs. Thank you, Vinicio, for the question. And now, I guess we don't have any further questions on the chat. I'll move on. We have only two more questions. Oh, sorry, we have one more question from Francisco. So once the bath level sensor was installed you reduce energy consumption per heat as a result of know the exactly amount of liquid steel? Thanks for your presentation. Do we have any data on that?
I mean, at Berkeley, I would think most places that there is a correlation between HEA level and you know, kilowatt hour per ton per heat, or however energy consumption per heat. So if you know, if the bath level measurement keeps us in that optimal range, absolutely.
Excellent. Thank you very much, Dan, and thank you, Francisco, for the nice question. So now we move on. We have only 3 more questions from the people that already registered the questions in the form. So the first one is, do you have equipment to temperature inside EAF to measure temperature? I guess to measure temperature inside EAF in refining period. In the EAF.
Well, yes, as you could see in the presentation, the solution that we are providing with those disposable sensors, they actually measure not only bath level, but they will measure also the bath oxidation and temperature. And this can, of course, be done during the primary refining with, of course, some limitations. And that will work for actually any type of sensor. If you're trying to measure something that is changing, of course, you're going to get some error. So the ideal for any sensor would always, we know we not always have time for that, but the idea would always to have a steady bath before we take any measurement of anything. But yes, the solution that we are providing already measures temperature as well.
Excellent. That's great. Thank you, Rafael, and thank you for this question. Now we have what are traditional means of mode level control, and what are the advantages of this technology?
Actually, we do have solutions for mode level control in Vesuvius. It's a slightly different subject because it's there in the caster, and this is actually managed within Vesuvius by our flow control team. So it's something that we could actually, Pedro, the person that made this question, if he wants to send me, of course, an email, or I can even redirect to a responsible person. It's another area of Vesuvius, but we do have solutions for mode level control via electromagnetic sensors. But those are not disposable sensors. Those are sensors that are there embedded or hanging in on the mold. But we do have it.
For sure. All the questions and all that have some follow-up comments or something, we can directly address them and look further into if we can find any solution that will fit their needs. We can get in contact and address directly to the proper specialist to handle each case. So then we will follow up in the emails and everything. So excellent, and thank you very much for the question. Thank you, Rafael, for the answer. And now there is the last question that we have in the registration forms, and it is, how long does it take to do the installation and commissioning of this system in an EAF?
Okay, so well, basically it's going to depend a lot on how much time we can dedicate to it with the customer, because in terms of the installation, it's absolutely not difficult. Basically, it's if we dedicate, let me say, 100% of our time ourselves and the customer, it's something that we could eventually do in 3 days, and then maybe another week or 2 following up. It's of course normally not what happens. Especially the maintenance people, electricians, they have a lot to do in a steel plant, so it never happens that quickly. So usually I would say something about 2 weeks, maybe 3 weeks, but the actual amount of work involved is not so much. It's basically the installation of our system, We have a pre-installation phase that Dan mentioned before, where we go to the manipulator, we measure the position of the manipulator and the output of the sensor. We usually use a laser sensor to measure the position of the manipulator in different positions. And then we come up with a BEF level equation between the output of the sensor and the actual position. And then you can quite accurately actually predict it. Then you have the installation of the steel lab, which is something that we do quite quickly. And we also require the help of the customer, maintenance or electricians to make the connections with the level 2 to actually take the sensor reading either from the PLC to our system or directly from the sensor to our system. So we have some working time there. And as I said, could be done very quickly if it was the only thing. Could be done in maybe 2 or 3 days. But in general, it's something that will take 2 to 3 weeks. And Pedro, if you allow me, just a quick comment, because I was looking at the questions. There's something that I didn't actually respond. It was asked also if it works in when melting stainless steel. Not so often the mills that make stainless steel use the oxygen probes for purposes of measuring the oxidation because of characteristics of this type of steel. But to measure BEF level, yes, it's possible. The main criteria that we have to attend is that we have to have a significant difference in oxidation between steel and slag. If this is possible, if this is true, then the BEF level measurement will be possible. Okay, as long as you also have an automatic manipulator.
Excellent, excellent. Thank you very much.
Well, one important thing, the question of the installation is usually we don't have to interrupt, the manufacturing. Usually on a down day, we can do the measuring, then we can do the background work on the algorithm and formula what needs to be put in place. And same with level 2. Level 2, we were actually able to do offline at Berkeley for sure. We were able actually to test it offline before we even implemented it. So it is relatively easy to install with the support.
Yeah, good point, Keith. It's not, when I mentioned 2 or 3 days or 2 or 3 weeks, it's not with the mill stopped, not working. It can be working for a few things. We may need one down day, right, Keith? May be enough, but not all this time.
Right. Yeah, there's stuff we can do in the background while the plants are running.
Excellent. Thank you very much. And also, I realize one question that we have here is actually more of a comment. It is from Nicolas, who says, thank you for sharing this development. I hope the Vesuvius people in our region offer this to us. So please, you have this the contacts disposed there that each of responsible to each region of Vesuvius that you can contact. And if you're not there in any of these regions, please reach out to us. You have here I just sent here the links for our LinkedIn pages. We have the Vesuvius technology, and the first one is the Vesuvius digital services specific LinkedIn pages. That's where we will be sharing the content, the link for the webinar video, and all this information. And please reach out to us. Which region are you from, Nicolas? That we will make sure that we will reach out to you in this, or otherwise I will just check in the registration form, and we will reach out to you with the specific person that should be addressed to this case.
Well, I just want to thank Dan and Daniel and Garrett again for supporting us and helping us and explaining how you use it and how it benefits you guys. It's greatly appreciated. Nucor is a great company, and yeah, we greatly appreciate your business.
Yes, definitely. we really appreciate the time, the availability, the partnership, and that you're here with us, and it really means a lot. It's very nice. We really appreciate it.
Perfect. Thank you very much, everyone. Thank you, Garrett. Thank you, Dan.
Thank you very much, everyone. Thank you, and we will be sharing this this session, the link with you, everyone, later. And thank you so much. Bye bye.
Thank you, everyone.
Have a great. Thank you.